Good morning. This is Arulmurugan, working as assistant professor in Kongu Engineering College. Today we are going to see about analog to digital conversion in PIC 16 of 877A microcontroller. PIC 16 of 877A, it's an 8-bit microcontroller. It's having 5 ports is available: port A, port B, port C, port D, and then port E. In this out of 5 ports, port A and then port E is dedicatedly used for analog interfacing. Totally it's having 8 channels is available. A0 to A7 totally it's having 8 channels is available. In port A we are going to use RA0, RA1 as well as RA2, RA4, RA5, and then in port E, RE0, RE1, RE2. So totally we are having 8 channels is available: RA0, RA1, RA2, RA3 and RA5 in the port A. In port E we are going to use 3 channels: RE0, RE1 and then RE2. With help of these 8 channels we can able to interface 8 different analog sensors. For example, it's maybe a temperature sensor or humidity or gas sensors. So we can able to interface 8 different sensors in these 8 channels. So totally in PIC 16 of 877A having 8 channels is available. So while we are process from analog to digital, with help of this digital value V in divided by V reference into 2 to the power of n minus 1. Actually the V in is nothing but the output of this sensor. For example, we are going to use some temperature sensor. For example, we are going to use LM35 sensor. Means LM35 having 3 pins is available. One was plus VCC, another one was ground, and then we have Vout is there. That Vout is the output of this analog sensor that is fed to input of our microcontroller, that is called by n Vin. The Vin is nothing but the output of this sensor which was given to input of our microcontroller, that is called by n Vin, and then V reference is nothing but that's a maximum measured voltage of this sensor, that is called by n Vref. Almost it's an 5 volt. How we are saying means whatever we are giving that plus VCC for our sensor, that is we will assign as an V reference, and then 2 power n minus 1. N is nothing but number of bits, bits which is depending upon the ADC bit, which AC ADC bit of our microcontroller. In PIC 16 of 877 we are going to use 10. We are using 10-bit ADC. So it is called by n 10-bit resolution. So 10-bit resolution means it's 2 power 10. So it is called by n 1024. The output range will the output of this 0 to 1023. So there are 1024 possibilities is available. For example, our input voltage to microcontroller, that means the sensor output is 5 volt, means the maximum measurable voltage of our sensor is 5 volt, means so 5 divided by 5, what will be 5 by 5 means it's n 1. 2 power n minus 1, 2 power n means it's an n is n. I already told with you it's an 10-bit ADC. So 2 power 10, 1024 minus 1, so we will get it in 1023. So 1 into 1023 we will get it in digital value was 1023. The digital value is we will get as an decimal value. While we are converting the decimal value to binary value, we will get as in 10 digit binary value. That's so the maximum desirable value was all are 1. For example, V in value was 5, V reference value is also 5, means so 5 by 5 we will get as an 1, and then it's a 2 power n. We are going to use 10-bit ADC. So for 2 power 10 minus 1, so 2 power 10 means it's a 1024 minus 1, we will get as a 1023. So that's 1023 is 5 by 5 will get as 1. So 1023 we will get as a digital value in decimal. While we are converting the decimal value to binary value, we will get it in all are 1. In case that V in value was 0, that means that our sensor output was 0, means what will be happen, the digital value we will get as in 0, and then corresponding binary values also all the 10 digits are 0. In case if we are getting that 2.5 volt is sensor output, that means we are interfaced to some some analog sensor. For example, you can consider it's an LM35. The LM35 V out was 2.5 volt, that was given to our microcontroller as V in. So what will be happen? V in divided by V ref, 2.5 divided by 5 we will get as an 0.5. 0.5 into 1023 we will get as an 511.5. So the corresponding binary value we will get as in 0 1 1 1 1 1 1 1 and then 1 1, except the first bit, the remaining all are we will get as in 1. Now let me discuss how to write a program to convert from analog to digital with the help of the CCS compiler. So go to PIC compiler. PIC compiler. Just create a file, another new project wizard. So we are going to convert ADC just I am giving the name ADC conversion. Crystal oscillator frequency we will give from 4 MHz to 20 MHz. The maximum crystal frequency is 20 MHz for our PIC 16 of A777A microcontroller. That's depending upon which oscillators, crystal oscillators you have. Depending upon that you can choose it, and then you can enable that power up timer. So to see the output, I want to enable that LCD display. I am going to interface then some analog sensor with the help of the analog sensors with PIC 16 of A777A. So the output we need to see with the help of the LCD display. Just I am enabling that LCD display D3, D4, D5 and then D6. In the LCD display we are going to use D3, D4, D5, D6. These are all things we are going to use for data transmission purpose. And then RS is called by a register select, which is used to select. It's in either command mode or data mode. Whenever RS was 0, it will be act as in command mode. Whenever it's RS equal to 1, it will be act as in data mode. RW, which is used for read write operations. And then we need to enable that analog pin. Actually I am going to interface only one sensor. So far I am going to choose only one channel. In case if you are going to use two sensors means, or two sensors or three sensors means, if you want to interface the sensors means, you can enable the three channels A0, A1, A3 or A0, A1, A2 like that. Okay, number of depending upon the number of channels you can select that. I am going to interface only one sensor, that's why I have selected A0. And then that's here the unit is available. In PIC 16 of A777A, it's a 10-bit ADC is available. So far what I am going to do means, I am going to select that resolution is 0 to 1023 and then give us create project. Okay, create project, it was created. Some default syntax was missed, that's why I have copied and then pasted here. Here it's a 10-bit ADC, that's why we are mentioning ADC equal to 10. Predefinedly we are selected it's an unit value of 0 to 1023, so it will becomes defaultly ADC equal to 10. In case if you are chosen 0 to 256 unit means, what will be happen here, ADC it will becomes as 8. However, it's in 16 of A777A having 10-bit inbuilt ADC IC is available. 10-bit ADC is available, that's why we have chosen unit was 0 to 1023, so it's come as ADC was 10. And then let me check here. Here already we have enabled that LCD enabled, that's why the default commands was generated here. The next comes to voids main. In this void main we are using long integer value. Actually normally integer value it will be very it can be possible up to 8 bits. It's a 10-bit ADC value, so it's the output will become a 10-bit binary value. That's why we are using that. It will be goes more than 8. That's why we are using long integer value. And then integer done we have considering it's done, it's one variable. We will discuss later. And then there are two floating variables we are taken. And then one was float voltage, another one was resolution. Resolution is V in divided by, that means the 5 volt divided by 2 power n minus 1. So 5 volt divided by 1023, it's in resolution value. Setup underscore ADC ports, it will be refers, I have selected that only one channel, that means A0 I have selected, so it will becomes AN0. In case if I am choose to only that A2 channel, means it will becomes as AN2. And then let me check about that while loop. In this while loop, initially we have to write a command, set underscore ADC channel 0, and then next read underscore ADC underscore start only. What will be refers means set underscore ADC channel means it will be start, it's a start of conversion, it will be starts to read from channel 0. Set underscore channel of 0, it's refers, it's in start of conversion. Once the SOV was enabled, you can give the 20 microseconds delay to settle the channel, and then you can read the value equal to the read underscore ADC. It's a command to read the value as a digital value, which digital value, and then let me check whether the process was completed. Check the process, we are going to use a command while it's not equal to done. While it's not equal to done means, that means ADC conversion was not completed, means again we have to do the operation until the process was completed. That's why we are mentioning done equal to ADC underscore done. In case the conversion was not completed, means what will happen, that loop was continuously, this while loop was continuously executing until complete the process. Once the process was completed, means we have to read the value. That's why what we are going to do means value equal to read underscore ADC. Once the conversion was completed, the digital value is read it and then stored it in the value. That value we have assigned as an long integer value. That's why I told with you why we are using long integer value means whenever it will be goes more than 8 bit, we will use an long integer. And then in case if we want to convert digital value to voltage, so what we do means the digital value into resolution means the 5 divided by 1023, while we are multiplying that we will get as an voltage, and then we have to print with the help of, we need to view the data. That's why what we are going to do means we are going to print the data in the LCD display. To print the LCD display, we are using that printf command, printf LCD underscore put C slash f a by c, the value which was which was read by our microcontroller, and then we are printing that voltage value which was converted with the help of this resolution multiplication. That's we will compile the program. Now you can open the Proteus, select file, new project. You can give the name. You can select that PIC 16F family. You can select 16F 877A, PIC 16F 877A. Components, LCD 16x2 LCD display. You can select then a 16x2 LCD display. So enable pin was connected with D0, enable pin was connected with D0, RS pin was connected with D1, RW pin was connected with D2. So RS pin was connected with D1, and then read rate pin was connected with D2, and then you have to connect D3 with D4, and then D4 with D5, D5 with D6, and then D6 with D7, D3 D7. Instead of unlock sensor, I have used one potential divider. I am using that one potentiometer. In this potentiometer, I need to give an input V reference. So just defaultly I am going to give the V reference was 5 volt to this sensor, and then I have to connect with ground. Another end I have to connect with ground, and then the output of the sensor we have to connect with RA naught, that means RA naught channel. Now the connections was completed. Now we need to load the coding hex code from which was already we have generated in the CCS compiler. So just edit properties, and then select the location. Here that ADC conversion, that hex file is available. You can load that hex file and then give OK, and then you can simulate it again. So it will be says that analog value was 511, and then corresponding voltage which was given to microcontroller is 2.49 volt. In case if I am making as an 5 volt, means we will get as in 1023. Just I am increasing, I will get the maximum value was 4.75. the 5 volt I will get the maximum value was 1023. The minimum voltage I will get as an 0. So 0, then the corresponding voltage was 0. Okay, thank you all.